Okay, this is the fourth video in solving linear equation series and looking at the balance method, three-step equations, but this time we are looking at equations where we have x's on both sides of the equation. So remember to put my pen up straight away this time. Let's have a look. Let's go straight into an example. Okay, example 1. Okay, solve 3x plus 1 equals 2x plus 10. Okay, so if you look at this equation, we have x terms, we have x's on both sides of the equation, on the left hand side and the right hand side. So we need to sort that out first before we solve the equation. So that's going to be our first step, and that is the extra step, making it 3 steps. So basically what we're going to do now, the first step, is to turn this equation into an equation where there are x's only on the one side. Now which side do you decide on? Because it doesn't really matter. But we are going to choose the side that has the most number of x's to begin with. So on the left hand side there are 3 x's, on the right hand side there are 2 x's, so I'm going to choose this left hand side to have my x's and get rid of any x's on this side. That way I will avoid some negative values of x, that's all. If you did choose the other side, you would have some negative values of x, and we'll look at that if that happens later on. So how do I get rid of this 2x term? Well, you quite simply, if you think about it, if I want to get rid of it, I want to make it 0. I want to turn it to 0. The only way to get 2x into 0 is to take away 2x. And if I do it that side, I must do it this side. Now notice where I am writing it. I am writing it underneath 3x. I cannot take away 2x from 1. I need to take it away from this term, because they are like terms. You can only take x's from x's and add up x's with other x's, if you remember. So working down the page, 3x take away 2x is x plus 1 equals 2x take away 2x is nothing, and then we have 10. We have plus 10. I don't need to write plus though, because it's on its own now, so we know no sign means positive. Oh, and now without thinking about it, I've actually created an equation that's got x's on both sides, but only needs 2 steps and not 3 steps. That's okay, because I wanted you to see this. Just because there are x's on both sides doesn't mean they're always going to be 3 steps. They usually are, but this one isn't. So because all we've got to get rid of now is the plus 1, because we're quite lucky, we've already got 1x there. So to get rid of plus 1, we take away 1, and you should be familiar with this by now. Take away 1 there. That leaves me with x equals 9. So in fact this one was 2 steps with x's on both sides. So let's look at one where I definitely know there'll be 3 steps and x's on both sides. Pen. Okay. Example 2. Solve 5x minus 2 equals 3x plus 8. So this time, very similar to the equation at the top, we have x's on both sides, x terms on both sides. We have numbers on their own on both sides as well, the same as up there. Okay, and so the first thing we need to do is to turn this into an equation where there are x's only on the one side. So which side am I going to choose? I'm going to choose the left hand side because there's more x's to begin with, just to avoid negative numbers, that's all, and to minimize my chances of making mistakes. So I need to get rid of this 3x because I want my x's over here. So how do I get rid of 3x? I take away 3x. If I do it that side, I do it that side, and I do it underneath the 5x because that's where I'm going to take it from. So 5x take away 3x is 2x. Minus 2, didn't touch it, so it's still minus 2. Equals 3x take away 3x, nothing. Plus 8, 8. So notice I'm working down the page all the time. I keep my equal signs in a line as well. So it's nice and clear for everyone to see, including myself. Right, now I've got 2 digits to get rid of, the -2 and the 2. And this is basically like the second video, the 2-step equation video, because that's what I've turned this equation into. I've turned it into a 2-step now. So I've done 1 step. So it was 3 steps, now it's 2 steps. So this is a 2-step equation, which you should be able to do. So we get rid of the -2 first, because that was the last thing was done to x. If you think about it on the machine, if I do it that side, I do it that side. That gives me 2x, that gives me nothing, equals, that gives me 10. Now I need to get rid of the 2. I transform into 1 by dividing by itself. That gives me x equals, and divide that by 2, 10 divided by 2, 5. Divide both sides by 2 to keep it balanced. Okay, so there's an example where we have x's on both sides, and it was 3 steps, because we were lucky up here. When we took away 2x from both sides, we ended up with just x on this left hand side. So we didn't have to do anything other than just get rid of the +1 and we were done. But this one, when I took away the 3 x's from both sides, just to get rid of this, I wasn't left with x, I was left with 2x. And so I had a 2 to deal with at the end, okay, which was the final step. And that's usually the final step. Okay, one more example. One more example. Example 3. Now this time, I mentioned this earlier, I'm going to say solve 2x minus 4 equals 7x plus 24. Okay, so this is not going to give me a nice answer, and also this time I've got more x's on the right hand side rather than the left hand side. So I'm going to keep my x's on this side because that's where most of them are, and get rid of this 2x. So I'm going to get rid of the 2x first. Okay, I'm going to say minus 2x on that side, minus 2x on that side. That leaves me with minus 4, because 2x take away 2x is nothing, minus 4 is left behind, equals 7x take away 2x is 5x plus 24. So now I have 2 numbers to get rid of. They just happen to be on the right hand side, not the left hand side. Don't worry about it. You just solve it in the same way, except you'll have your x over here rather than over here. And there's nothing wrong with that. So what's the first thing we get rid of? It's the plus 24. How do we get rid of that? We take away 24. Do it that side, do it that side. What's minus 4? Take away 24. It's minus 28. Equals 5x, didn't touch it. Plus 24 minus 4, minus 24, nothing. That's why we did that. So now we're down to sorting out the 5. And this is what I meant by earlier saying it's not a nice answer. But that's okay. I wanted to show you 2 things in one example here. So the one thing was putting a larger number of x's on the right hand side and showing you that it doesn't matter. We'll choose them over there and work over this side. And secondly, that not all answers are nice. And what I mean by nice is nice whole numbers, either positive or negative. It's not nice because 5 does not go into 28, does it, nicely? But it doesn't matter. That doesn't put me off. I know to get rid of the 5, I have to divide by 5. Because I've got 5 divided by 5 is 1x, which is what I want. If I divide that side by 5, I divide that side by 5. Okay. I've got an answer that's not very nice. Now there's 2 things you can do. You could leave it like that, especially if it was an exam, and you would get all the marks. Okay. Now we call that an improper fraction, because the top is bigger than the bottom, or sometimes we call it the top heavy, but the correct word is improper. You could leave it like that, or you could change it to a mixed number. Remember, improper fractions, can be turned into improper. It can be turned into mixed numbers. And this is what we do. We say a minus divided by a plus first. Let's do the signs. Well, we know that's negative. Then how many 5s are in 28? 28 divided by 5. Well, there are 5 5s are 25. So 25 of those fifths are 5 whole ones, with 3 fifths left over. So you could do that as well. But it's quite acceptable just to leave it as your fraction. So don't worry if this number does not divide into it. I would, if that happens in an exam or a situation, I would just check your workings out to make sure you haven't made a mistake. And if everything looks okay, leave it like a fraction. Don't go messing around with it. But you should be able to turn this into this. That is an aim of ours too. Okay, that's the end of that video, and thank you very much.